Good morning, everybody. Welcome to the Unit Analysis Mystery Lab. In this lab, you're going to be reacting what's called mossy zinc. It's zinc with a little bit of an oxide layer on the outside. It reacts really well with hydrochloric acid with, as you can see, 2 molar hydrochloric acid. Your first goal today is to get 45.0 milliliters of hydrochloric acid. So I want you to pull these beakers out of here. There's a lot of hydrochloric in here. You've got your goggles on, of course. And roughly pour to about 45. Get as close as you can, but don't worry too much about getting it perfect with the beaker. Then I want you to take the pipette that's in there. And, oh, looks like I'm a little shy. My eye is level with the bottom of the meniscus. That's that dish of water tension at the top. And I'm just going to add a little bit until that meniscus is sitting dead to rights on that line for 45.0 milliliters. Now let me show you a safety tip. It's really hard to tell which one of these puddles is water and which one is hydrochloric acid. Obviously, they look exactly the same. So if you have a spill at your table today, I want you to assume that it's hydrochloric acid, because you don't want this stuff lingering around on your clothes or your hand, especially splashing into your eyes. That's why you're wearing goggles right now. So we've got baking soda out. And baking soda is a powdered base that's going to neutralize this, one of these spills. And here's our test. If I take a little bit of baking soda and put it on this puddle, nothing happens. All right, that puddle must be water. And if I put it on this puddle, I get effervescence. Those bubbles are carbon dioxide. I make table salt and water and carbon dioxide, and I keep adding it and spreading it around until the bubbling stops. And once the bubbling stops, I've adequately neutralized this very minor acid spill. And then you can grab some paper towel and just wipe up the mess you just made. Now you guys are going to measure out the mass of your zinc. Place your weigh boat on the scale, let the numbers settle down, hit the 0 button, which is the tare button, zeros it with that on there. And then here's your zinc, and you'll have forceps, or tweezers. Take your tweezers, and look at that piece. That's great. I want you to put 2 to 3 grams in your weigh boat. I know you guys have calculated an amount of zinc, a perfect amount of zinc that you should have. And it's just going to be hard to get that mass of zinc because we're dealing with such large chunks. So don't go over 3 grams. If you hit 3 grams, 0.00, that's great. Less than that, great. If you hit what you calculated, that's a miracle, even better. Just try to hit between 2 and 3. All right, now the fun part. We're going to create a reaction mixture. Take our 45.0 milliliters of hydrochloric acid and pour that into here. Once you do that, I'd like you to go over to the sink and rinse this graduated cylinder out a couple times. This will keep them clean all day and prevent them from getting sticky for the other classes later in the day. You've got your hydrochloric acid now, and you've got the zinc that you've weighed out, and you have written that down on your lab. And you're going to have your partner grab the base of the Erlenmeyer flask. And that's to keep the flask from tipping over when you put the balloon on top. Let me show you what I mean. You'll put your zinc in, and as soon as the zinc is in there, you're going to take your balloon and get about 4 fingers in there, 2 fingers from each hand, and pop that over the top of the Erlenmeyer flask. Our hypothesis is that the zinc is going to react with the hydrochloric acid to make zinc chloride, and then the hydrogen is going to steal valence electrons from the zinc. The hydrogen's more electronegative than the zinc and more reactive. So it takes those electrons away from the zinc and forms pure hydrogen gas. But we want to be able to test that theory. One thing that we know through research and experimentation is that hydrogen is explosive if in the presence of an oxidizing agent like oxygen. So we have some hydrogen. We suspect, we're hypothesizing is accumulating in our balloon. And we're going to wait until the reaction down here in the flask between the zinc and the hydrochloric is almost done. All right, we're going to remove the balloon now and do a test for hydrogen. But before you do, I want you guys to notice my reaction's still going pretty vigorously, and you can wait until your reaction dies down and the bubbles stop. Wait as long as you want. The last part of this really only takes a couple minutes, and so you can wait all the way to the end of class if you want to. Now, I do want you, before you pull that balloon off, grab the bottom of the flask and do a temperature test, just a hand temperature test, relatively to your hand. Does that flask feel warm or cold? And that'll tell us if heat is coming out of or going into the reaction. And I just find that interesting. All right, now you're going to remove the balloon. Your partner is going to put their hand back at the base of the flask again, and that keeps the reaction mixture from spilling. You want to pinch, you can even twist and pinch the balloon, and then roll the balloon off the top of the flask like that. Now once the balloon is off, let's see if I can remember how to tie a balloon. Hey, that's not bad. If you have a hard time tying balloons, don't worry about it. Just ask one of us and we'll come over, either myself or someone else near you who knows how to tie a balloon, and we'll tie it for you. Now for the hydrogen test. So you've got your balloon, and there are these meter sticks over in the center of the room on the center table, and tape. And so take the tape and just tape your balloon to a meter stick. It doesn't have to be fancy. It just needs to hang there like that. For this part, make sure your goggles are on, and so you've got a Bunsen burner flame here in the middle of the room, and your balloon is filled with a gas that we're hypothesizing might be hydrogen, and we can prove that it is if we put it in this flame and it explodes. So what I want you to do, again, make sure your goggles are on, and I want you to yell, "Fire in the hole," and put the balloon into the flame. But don't put the ruler into the flame, just the balloon really quickly. And you'll say, "Fire in the hole!" Awesome. That was a positive test for hydrogen. There are these water bottles that are out here. And if your balloon lights on fire, I want you to use these water bottles as fire extinguishers to put your balloon out, because burned rubber smells horrible. You guys, thank you very much. Good luck today, and have fun with this one. It's our first chance to blow something up.